Well, hi, good morning. Thanks so much for joining me in my shop here on July 24th. A gray day promising to be a very rainy day coming. So it's a good day to be in the shop. And I think what I'm going to do today, I'm going to try to do two things today. One is replace the remaining few paper capacitors. 1, 2, 3, 4, 5, 6. Actually 6 of them. 6 that I can see right now. These are all in the RF or front end of the radio. And then after doing that, I'm going to want to assess the general condition of the radio, not so much by listening to it, but by making measurements, in particular voltage measurements across all the tubes. That could identify more component problems, or may show that the radio is now in a good operating condition. So that's what I hope to do today. Bearing in mind the mystery wire is still hanging here, the wire of mystery, which is called that. Now when I look at the capacitors here, I see this one's a little bigger than the rest. So I think I want to start with this guy. But I just remembered. Yesterday I changed 6 capacitors, I think it was, and I didn't test them. So I think I'm going to revert to testing the capacitors I changed yesterday down in here. We'll run through them on the tester, and then I'll get busy on this one in particular. Find out what this one's doing. It's soldered down to the chassis there. It's bigger, so I think it's probably got an interesting job. Okay, let's switch over to my capacitor checker here. These are the capacitors. Now hopefully when I cut them out I left enough wire on the ends that I can do a test. That's what I was trying to do. And we'll see. Sure looks bad enough. Okay, on 50 volts, watching the eye. Watch the eye. Right open. 150. Right open. 250. Oh my gosh. Well, there you are. Let it be said. So this is a 0.005 capacitor. Just giving a moment for discharging. Let's check it. 0.005. It'll be this scale. I think it'll be the best one right here. This is a scale ending 0.5. 005 is here. Watching the eye. Okay, so now you may not be able to see this on the camera, but the eye is trying to open. It's not. It's in the right spot, but it won't open. That usually indicates a leak in the capacitor. Not that I want to spend all day testing capacitors, but I get curious about things that don't add up. You're not adding up. Let's try another instrument here. Certainly on brand new capacitors, I found this instrument, and this one too, to be accurate. There we go. So this says it's a 0.0066 microfarad capacitor. It's supposed to be a 0.005. It's reading high. So these are indicating a leak. How come my test didn't show the leak? Now we are now testing the test. You can hear the dinging of cat bells as my cats are slowly approaching me here. Again, we'll go back over here. 25 again. And it just pops open. I can see it charging too. Well, it's mysterious. Got conflicting indications. Not the worst capacitor, that's for sure. Let's try another bad looking one here. Could be that the job the capacitor does in the radio has an effect on its life. So if it's under a fair bit of pressure, from voltage, maybe its life is reduced. But another factor would be how hot it gets. If it's sitting in a hot spot in the radio, it's going to shorten its life, I would imagine. Here we go. It popped open stupidly fast. Oh. This is a very, very small capacitor. I'm not going to be able to read the value on that. How small? I can read it. I can see it there. So this is the speed at which the capacitor checker operates indicates the amount of capacitance in the capacitor and how long it takes to build a charge. This is a point, looks like 0.001. That's a small capacitor. Okay, that's all that is. Well, now this radio did work right from the start. So even though one of the capacitors was catching fire. How about this guy? Here we go. These are all, you know, in terms of radios of this vintage, I've fixed many. This guy's capacitor is not very sick, except one that caught fire. Here we go again. 50. Not quite. Yeah. These are all coming into the. This is a different style here. Maybe this one will test really bad. My cats are ganging up out there. Here it comes. There it comes. You guys, it's raining outside now, and it's going to be raining all day. So you're going to have to get used to it. Yeah. Right open. Right open. Well, one thing I have noticed when I've been doing this testing of capacitors I'm removing from radios is they are consistent across the radio. So in other words, generally they're all bad. They're all in the same state, let's put it that way, of badness. This radio, not so bad. Here we go. 50 volts. Yeah, literally these are among the best old beat up capacitors I've ever taken out of a radio. Yeah. Okay, we can't expect too much improvement putting new ones in. These ones are bound to be in the same condition, I would think, even though one burned up. Now, why would one of them burn up and none of the others? So located right in here. This is not a hot area in the radio here. A hot area is close to the base of the tube sockets. That would be a hot area. I don't know. Kind of a mystery. Okay, so we've checked the capacitors I did yesterday. Let's go after this guy. So before I cut him out, just see if that looks like a replacement in there. Let's take a look at this with the other camera because it has some suspicious way it's installed there. Yeah, I hear ya. Well, I don't know. Certainly looks the same as all the rest. Hard to tell. Okay, let's find out. I'm going to find out. I'm going to play with my cats for a little bit, and then I'm going to find out where that capacitor is and what it's doing before we change it. Here I come, cats. Okay, on my last video, I made a bad video error and left an image up on the screen, which I didn't notice, sitting and covering this part of the screen here. So if you watch that video, I apologize for that. Well, I just did the same thing looked at the schematic and for 10 minutes talked about it and then realized, oh my gosh, the whole thing's obliterated by this image. So the image is gone now. I have to repeat what I was doing. Oh, okay. And I just hate that. I hate, rework is the death of all projects. Okay. Now, we were hunting down the capacitor. I'm going to tell you it's right here. This is the capacitor I was pointing at. It's only a 0.05. Where'd it go? There he is, 0.05. And what's it doing? Okay, so here it is attached to the tube in question, on the pin in question, right to the screen. Element of the tube. And that's not the only tube. We follow the wire across. We come into here, we come into the screen. The screen is between the grid and the plate. That's where it lives, between the grid and the plate. And look, the wire doesn't stop, it keeps going. Because there's another 6 SK7 at the front end of the radio, and there's the screen there. So you can see quite clearly here how the different grids are positioned. So what's the screen doing in there? The screen is making the grid unable to see the plate, or the plate unable to see the grid. See it in the sense that each one is influencing the other. Now, I know you might, wait a minute. The grid's all about influencing the plate, isn't it? No. The grid is about influencing the flow through the tube. Doesn't necessarily have to know what's going on beyond the screen. The real purpose of the screen is to reduce the inter-electrocapacitance between the grid and the plate. Before the screen idea was developed, and you just had triode tubes with just a grid in the middle, what was found was when you tried to operate them at a higher frequency, they just wouldn't work. Or if you tried to introduce them into an oscillator, you'd a higher frequency, they just would not work. And eventually it was discovered, or was known, that in effect there's a capacitance between the plate and the grid, a small capacitance. And that capacitance acts a little like a short circuit, if you like, between the plate and the grid. Not quite, but you kind of think of it that way. Limiting the operation of the tube to lower frequencies. Somebody along the line discovered that if you put another element in the tube here, charge it up to a voltage similar to the plate, then the plate cannot see past it, and the grid cannot see past it. And it reduces the inter-electrocapacitance to the point where the tube can be operated at a much, much higher frequency. Now that's the story of the screen, except there's a problem. If you stick a screen in here, a grid of wires, and charge it up to a voltage similar to the plate, it's going to act like a plate. It's going to take current. It's going to rob some of the current that's going through the tube, a portion of it, in the course of doing its job. Another problem is when you stick another element in the tube, any signal on that element may get amplified in the tube. And what signals would be on there? Well, this is a radio full of signals. All kinds of stuff could get on to this wire from other tubes, because the wire is connecting all these tube screens right together, solidly. So how are you going to stop that? This problem of signals. For instance, out here the signals are strong, here the signals are weak. Here the tube is very sensitive to low signal levels, not so much here. We have the strong signal coming out here. If it can find its way back on the screen line, where'd it go? Screen line, here. It could find its way back to here, to come through again. They go around and around, around and around as an oscillation. So radios where this capacitor has failed, and they are unable to stabilize this line into a nice clean DC voltage, and instead it has variations on it, signals and whatnot, radios often will exhibit a condition called, hey, what happened? I'll tell you what it sounds like. It sounds like this. Pop, 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 pop. Various rates and various qualities of that. Motorboating. They call that motorboating in the radio. It has to do with the fact that a strong signal is leaking back into the system, and the strong signal then is triggering the automatic volume control, which we haven't talked about. The automatic volume control is turning down the strong signal. Then strong signal disappears, the automatic volume control turns it back up. And this effect results in the put, 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 put sound you hear in the radio. If a second problem can occur, you can get a straightforward oscillation through here. And that'll sound like a howl coming out of the speaker, a whine, a howl, a screech, whatever you want to call it. And the worst case is you can get oscillations in here that you can't hear. They don't come out the speaker, and they're there, and they're busying up your radio, but you may not even know they're happening. That may be the case with this radio, I'm not sure. So that's what this guy's doing. Now there's another 0.05 in here. Why don't we just carry on and find it, because maybe it's doing something similar. This is on the very first tube, so we'll look for a 0.05, 005. Here he is. 0.05. So what we've got going on here is we have a cathode resistor. It's a very small value, 330 ohms. Fair size resistor, half water. So the tube current is going through here, causing a voltage drop, raising the potential of the cathode, making it a little bit positive relative to the grid. And that's how you get the grid bias here with this. This capacitor is the bypass for this. Now there's going to be only 5 or 10 volts here. This capacitor is not subjected to much torture. So how worn out is it? Based on all the capacitors I've done so far, this one's probably in pretty good shape. This guy, on the other hand, is taking a beating all the time. He's got 300 volts pushing on him, 250, something like that, pushing on him. He's taking a beating. Be interesting, these two capacitors are the same size and type. Why don't we take them out and compare them? Yeah, that sounds like a good idea. We'll have to keep track of which one's which, and we'll see if the one that sustained the voltage is in worse shape than the one that had an easy time of it. Where'd he go? The easy time of the guy. I lost track of him. He's bypass here. Easy time of it over here. Both of them 500 volt capacitors, right? Yeah. A little bit of overkill here, that's for sure. Okay, we're going to do that. Okay, those two capacitors are replaced. I have them over here, waiting to find out the truth. Now, so what happens? So these two capacitors are essentially identical. I've marked them so I can't get mixed up. I marked them somewhere, somehow. It's very hard marking wax. There we are. So this is the screen guy. We'll start with the screen one. This is the capacitor that is doing basically heavy duty work every time that radio is operated. And I don't know, does that actually wear them out? I think it's more about temperature, but here we go. 50 volts. Watching the eye. Oh, hey, down here a little further. Okay, so you can see the gap. Here we go. 50 volts. Right open. 150. Okay, it's getting all the way open. 250. Starting to have some trouble now. It's just barely opening. So opening a little bit at 250. It's jumping around. Is that the switch here? $250 is the limit for that guy. Now this is the one. This is the guy who's been living on the lazy river. Never seen high voltage till now. Woo! First voltage isn't high, it's only 50. Here we go. Open right up. 150. Pretty much the same as the last capacitor. It's opened right up. 250. This will separate the good guys from the bad guys. It's opening up much more, but not fully. These are 500 volt capacitors, so I can give it a 350 test. Yeah, so now it's opening up at 350, just like the last one opened up at 250. So, not perfect, but hardly terrible. These just don't qualify as terrible. Plus, both of them are in positions where if they're a little bit leaky, shouldn't mean anything. There's many milliamps flowing in the circuits that they're in, and a few microamps, or even microamps flowing through a capacitor is not going to disturb things. So my guess is these two new guys not going to really influence the operation of the radio very much. Now we got 3 more to do, I think. 1, 2, and 3. 4. We have 4 more to do. Just every time I look at it, there's another capacitor in there. Well, this one looks pretty innocuous. It's going to the chassis. Yeah, it's going to the chassis. So why don't we find out what this one is? This is on. It's on the first IF can here. One of the terminals of the first IF can. I'm not even going to bother operating the radio because I'm pretty sure the 2 capacitors I've done aren't going to make any difference, and I didn't make any mistakes. That's what I think. So we'll go after this guy. Why not? First IF, and how big is it? It looks like 0.02. Looks like a 0.02. It looks like it's been crushed here a little bit. Probably nothing. It's probably nothing. 0.02 on the first IF. Let's go see where that guy is. So here's the first IF can, and we will be looking for a 0.02. No. Maybe on the other side here. Maybe anywhere on this line. Here's a 0.02 right here. 0.02, 500 volt. Okay, so what is it doing? Appears to be supplying a signal ground, if you like, at the bottom of this coil. It also all signal ground on this line, so a signal ground applied at the bottom of this resistor, bottom of this one too. If this guy were not there, well then these points would be connected together. They're not really now. They're sharing a ground point is what's going on. But if this is weak or out of the picture, well, you'd have signal, I would think, going right back. You'd have a schmozzle here. That's my guess. 0.02. It's another one whose job is to quiet things, and it's not sustaining much voltage at all either. 0.02. So we'll change that one out next. Okay, so I'm getting ready for the next capacitor. I'm probably going to go after this one down here, but that's caused me to look at these wires. This doesn't look right. This just doesn't look the way these radios usually look. Like this wire, just hanging out here like this. So the normal thing is, you're going to run a long wire through a radio like this. You run it down along the surface of the chassis. That is supposedly helpful. If we look at this wire here, just going right past these coils, right over these wires. It's not that it's making electrical contact, but that this is the antenna, incoming antenna line. This is the signal coming from the antenna. It goes on this wire, past all this stuff, goes down in behind, and eventually connects to, can you see it here? Connects to this big coil here. Wires back here. That's not normal for a wire like that to just run kind of like just over top of everything. These other wires all look just They don't look right. Now, am I going to start moving all this stuff around? On the assumption that I think I know what I'm doing? Or is this somebody's previous efforts in the radio? They've done something and then they removed these wires and put them back on? Remember, this thing was untwisted. So somebody was in here fiddling around trying to figure out what's going on. Could they have unsoldered wires and then resoldered them? There really isn't a lot of play here. Now the thing is, if these wires have not been fooled around with, and if this is the place they're supposed to be, as crazy as it looks, including this thing, if I move them around, that may change the operation of the radio and even hobble the radio. And then how would you ever know it was a wire and which wire it was? How would you ever know? You'd have to fiddle around for ages. So I think I'm going to leave that alone. Only if the radio's failing to operate and I can't figure anything else, I may come back to fool around with these wires. But I mean, this isn't going to stop it from operating. This may weaken it or cause oscillations in it. Things like that. I still have the mystery wire here. Okay, there's a great big resistor here. Something red-orange, so it's something like 1200K or something like that. Why don't we measure it and see what it is. So you see a big high wattage resistor. Now, I may have done this one earlier, but we'll do it again. Of course, I'm measuring it in circuit, which has problems. Let's see what we get. It's bigger than 6,000. Yeah, I said 1200, but I don't know. I can't read the first color. 12,000. Okay, so I remember seeing a 12K resistor in there. That's good. In the schematic. Okay, that's fine. So I decided to leave the wires unless there's an indication of the need to fiddle with them. Now this is the reason I really got into this capacitor here, that you can barely see my finger on it, way in the back there. There it is. It's hooked up to a single terminal strip here, and then a wire goes from there over to here. It's also kind of pulled out of place. You would just think that would be pushed down onto the chassis. But I don't dare move it for reasons I explained earlier. So the capacitor runs from this terminal and then down to here. This is it. This is the connection here. So I got to replace the capacitor up this way. Okay. I have nothing better to do today. You know what happens with the weather reports around here? It's very hard to predict the weather around here because of the large lakes that are around us, and the weather reports are often just wrong. Come on, click here. The weather reports are often just wrong. Oh, I think this is a tough one. Wow. So today, last night, rain starting at 5 in the morning, continuing throughout the day. This morning I got up, rain starting at 10 o'clock, continuing through the day. Well, it's well past 10 o'clock and it hasn't rained yet. Okay, I'm going to get this ready because I'm cutting out, because I want to mark this terminal right here. Okay, whoops. Get them right off. We'll come in through here. These coils. Don't cut the wrong thing. Whoops. There it goes. So with all these new capacitors in here, this, when I'm done, this radio will probably operate, you know, except for the tubes. The tubes wear out. Probably trouble-free for decades to come. This is a another impossible to read capacitor here. Cannot read the value. I can see the voltage, 500, but the value is really messed up in here. Okay, so that one is going, I gotta start here, from this pin, from this thing. Oh, I know where that is on the schematic. So one end here, look for a capacitor on one end, one end of that thing, one end of that thing. So where do we find? We go up this way, and here's a capacitor. 0.005. 500 volt. Connected to the, there's many grids in here. So this is the third grid, the signal grid. This is the antenna signal coming through this capacitor. Really? That's a pretty important capacitor. The whole show is going through it. 005, and it's connected to the 6SA7. Let me get my book out here. Okay, 6SA7. Where is group 3? 6SA7. 6SA7. Third grid, G3, is pin number 8. So pin number 8, I'm losing track of what I'm doing. Is that pin number 8 up there? It is. Pin number 8. So that's a 0.00. And what did I say? Let me just peek at the schematic here again. So we've determined it's this guy, 0.005. Does that make sense with this? Can I get 0.005 out of that? It's the right size, I think. Well, yeah, maybe. I can't really read it. 0.005 is the winner, and it's carrying the signal. It has not got a lot of voltage on it, I'm pretty sure. I can use a lower voltage capacitor here. 0.005. I don't have any lower voltage ones. I just have these high guys. Okay, okay, install this capacitor. Okay, got a new capacitor installed there. Let's test this guy, because if I'm reading the schematic right, all the signal goes through this capacitor. Don't think this is sustaining any significant voltage across it. Okay, here we go. Watching the eye now. Right open. Not so good here. 150 volts and it's balking. So again, a little bit of microamp leaks may not be significant there. Better gone than not, though. Now I'm left with 1, 2 more to go. Maybe I should test the radio. Maybe make a brief test of the radio just to make sure it still operates. And I haven't moved it up. I think that'd be a good idea. At this point, let me just make my bench a little safer here. Everything away from the radio. Okay, I think we're explosion proof now. Plugged in, speaker in, no antenna. That's fine. Broadcast band. Dim lights. Okay, dim lights behaving fine. Just going to put this capacitor in at one point, but the leads turned out to be just a little bit too short. Okay, volume up. How about power up? Power up. Volume up. Thank God. Tuning. That's a weird stuff there, but well. That's a little different. That buzzy sound. Something making that sound. But we don't know what. Something external, I'm going to guess. I'll stick a ground onto the chassis here. Get louder. So many things that can't be explained. At least explained by me. Okay, but the radio's operating. Didn't really sound wonderful, did it? Okay, now we got a couple more to go. And coffee break time has come. Okay, let's go for this one next. There's just this one and one back here, and then I'm done. Fantastic. This guy is hooked up to this little coil here. You can kind of see it. This coil. See, there's another. It's actually a transformer, and there's a transformer here. And if you look down lower, you see these larger coils, and you also see that the radio is sectionalized this way. This plate is an important divider between what's going on in this area and what's going on in that area. That's to make sure electric fields can't influence each other. So I think what we've got here is these are the shortwave coils, and these are the broadcast coils. So this is the oscillator broadcast transformer, I guess you could say. So from here we can get on the schematic, and then we're going to look for a capacitor like this. You know, that's like a 0.05, 0.01, something like that. Okay, so let's jump onto the schematic. Okay, we've jumped onto the schematic now. So here's piles of coils, right? Here's the big coil I pointed to and said something about shortwave, and then here's a separate transformer. This is a transformer here too. Separate transformer for the broadcast antenna coil. If we just go across, here's another one of those. And here's another one of those. Just like we saw on the radio. So the coil in question then, the transformer in question, would be this one. This is the one the capacitor is connected to. So now we'll take a look, and can you see, oh, look at that. There's a capacitor right there, 0.01, 500 volt. And it's taking B+. You can see that this goes up through that to the plate. So there's a B+, there's some couple hundred volts on here, maybe even 300 volts on here. So this capacitor's taking a beating, voltage-wise. It comes down into the switch, and good grief. Yeah, that's the end of that. So, exactly what this guy's doing, I think it's providing a ground sometimes. I think sometimes this is grounded. This line here. Okay, well, we'll just change that one. I'm not sure the influence on the radio exactly. If it's providing a signal ground up into here, if this guy's not working well, if the capacitance is low, perhaps the signal ground isn't effective, and that would weaken the shortwave side of things. And then when you want to use broadcast, you'd remove the ground from down here, and this is just sitting here doing nothing when you're using broadcast. I think that's probably what this is kind of doing. Grounding the upper transformer. Primary. Enough said. 0.01, let's change it out. Okay, we've removed all the old capacitors. Let's test these last three, just for consistency's sake. Okay, we're on 50 volts. Put this here. Watching the eye. Opens right up. Not so good at 150. Not a particularly good capacitor. Let's put this one right here. This one I'm holding, I think, conveyed the entire signal in the radio. 50 volts, right open. 150, right open. 250. And you wonder why this radio works. Let's give it a 350. I won't hold it though. All the way up to 350, it's not bad. Yeah, there's a reason why this radio is working. Now, this last one here is working because the capacitors weren't shot except one that caught fire. So yeah, it's all in pretty good shape except one is on fire. There we go. Right open. Right open. Right open. Surprising how good these are. To me, the radio must have been taken care of during its life. Must have been indoors in an air-conditioned house or something like that. Something like that's going on, I think. Okay, we're going to stop, take a little break, then we're going to test the radio, and then that'll be it for today. Okay, let's give the radio an all-band test here. Total number of capacitors I've changed out on this guy, 15. 15 capacitors. Oh, smokes. Let's see what kind of difference it makes. Volume down. The antenna's connected at the back. Just letting that dim light thing happen. It looks pretty good. Okay. There we go. Broadcast band to start. Lots of volume. So we can pick stations up. There should be one French one here. Say no on that. Okay. Should get the station right around here. Okay, so that heterodyne tone, the very high pitch, I think that's indicative that it's trying to pick a station up right here. Could be, you know, I have a couple of outdoor antennas. I'm switched to one of them. It could be the antenna I'm using just isn't great for broadcast. Actually, none of them are great. Okay, so this is the C band. It goes all the way from 6 up to 18. Covers the whole shortwave spectrum. Well, not the whole thing. This is the has a low response. Look at how high I have to turn the volume up here. Way up. Still weak. This time of day we should get stuff up around here, around 9.
Years after the death of the last apostle, a lot of stuff coming in, even in Jude's day. He said, let us earnestly contend for the faith that was once delivered to.
Okay. Just look for anything else. That's a very, very strong station. So we know the radio's working. Doesn't seem to be very sensitive on this band.
How is it that
There he is again. I think it's the same station. And maybe right in here. No. That's that one strong station.
putting up?
Okay, not the best showing there. Next band, it's a 9 megahertz band, spread band. Lots of volume now. Now that strong station we heard on the other band is at 9.3 and 9.3, so 9.4, 5, 9.4. Well, that's not right. 9.44, 43, 42. It never gets anywhere near. 9.3 is way out here. It just doesn't get there. You know, as time went by, governments expanded these broadcast bands for shortwave because there was so much traffic on them. Where is everybody now? Where'd they all go? Okay, next band, 25 meter band. This one should be picking stuff up. We should be hearing stuff. Nobody home. Last band should be picking stuff up here too. Now this band, in reality these days, is actually double the size. So there are stations up here. We're not going to hear them. Nothing. Well, it's a little bit surprising. Okay, that's fine. Because we have a pile more stuff to do yet. We have the voltage test. I'm not going to do that today. I'll do that tomorrow. This verifies that the tubes are operating properly within the proper operating parameters, voltages and that. That might lead to a defective resistor or something else. Who knows? And then following that is the alignment of the radio. Ooh. Didn't like that sound. Are we moving the power cord? Okay, don't know what to make of that. The radio's still here. Good. Okay, so those are the two next stages to go through. The voltage tests and then the alignment. And then we'll know. Then we'll know the truth. Thanks a lot for watching, and we'll see you tomorrow.